Okay, let's get into the programming part now, and let us understand the code which is available. So we have NumPy, SciPy, Pandas, Scikit-learn or Sklearn. We have Statsmodels. We have Matplotlib, Cbon, TensorFlow, Kasas, PyTorch. And when it comes to natural language processing, we have NLTK, TextBlob, Jensen, regular expressions, Spacey, etc. Right? Always you need to remember, of course, you have word cloud and things of that kind. So always remember the at least library names which are used in the space of data science. What do we use for network analytics? Right? What do we use for text mining and NLP? What do we use for our other supervised and unsupervised algorithms? Yeah, it always makes sense. What libraries do we use for data pre-processing? There's something called as feature engine. Okay, so now let's get to this. We have Pandas, NumPy, Scikit-learn. From Scikit-learn pre-processing, we are importing label encoder. And then we have the data here, credit.csv. Let me go to that dataset. Let me copy that. We have data in which you have 1000 rows and 17 columns. In this specific data set, given all the various inputs, we need to classify whether a specific customer would default on the loan, yes, or not default on the loan, no. Okay, this is the business problem. Is this classification problem or regression problem, friends? If you have output variable, which is discrete, and if it is categorical data, is this categorical data? Yes and no, or continuous data? Categorical data. So here, this is categorical data. When you have categorical data, okay, how many classes do we have here? 2 classes. Then it's called as a 2-class classification problem. It's called as classification problem. If you have a number, numeric value that you're trying to predict, then it's called as regression problem. If it is categorical data, it's called as classification problem. So what problem are we trying to solve here? Classification problem. Here we use inputs. Okay. Do we have any null values? Go to the data. Is there any null value? If yes, show me the summation of that. Do we have any missing values? Not really. So you need not worry. Absolutely. If you have any values, for example, NA values or null values, etc., when you say drop NA, it's going to remove all of your NA values, but we do not have any, so we need not worry much. When I say data.columns, it will show you what are the various columns available. When I say data.info, it's going to give you more information about your data set. It's saying that you have 1000 entries. Entries are nothing but rows. You have 1000 rows. And saying that index values are from 0 to 999. Obviously, indexing in Python starts from 0. And you have total how many columns? 17 columns. So all the columns, right? And you do not have any null values. Non-null values are 1000. Out of 1000, 1000 are non-null, not null. Meaning how many null values will be there? 0. And for each and every variable, is it categorical data or is it numeric data is provided. Categorical data in Python is called as object. Categorical data in Python is called as object. For example, checking balance, less than or equal to this is one class or one category. 1 to 200 is another class. Unknown is another class. Right? In that way, you have multiple classes. So it is showing up as object. Here, months, loan duration, these are all numbers. And these numbers do not have a decimal value, hence they are called as integers. If any of these numbers have decimal values, then they'll be called as float. Absolutely. Okay. If you feel that, you know what, phone, whether that is what your common sense says. That is what your domain knowledge says. Then what do? You just remove that. You say data or drop this phone. Axis equal to 1 means column. Axis equal to 0 means 1 means column. Go to this column called phone, drop it. So if I drop this one column, how many columns will I have now? From 17, it will become 16. Run it, and there we have 16 columns. And you're saying data or describe. If you just run that, you would get the description on what is each and every column. What is, how many values do we have? What is the mean, standard deviation, minimum value, max value, 25th percentile, 75th percentile, and 50th percentile. But if you want to store that in another object or variable, sure, you can do that. When you say equal to, it will get stored. For every column, you have the details. Here I have 16 columns here, but it's showing only 7 columns and 8 different values like count, mean, standard deviation. All these are 8. This I understand, 8. But then why only 7 out of 16? Numeric, okay, absolutely, you're right. Only for integer or float, that is only for numeric values, you can calculate mean or standard deviation or minimum or max or any of the percentiles, right? So how many numeric values are there out of 16? 7. For all of those, you get these. Good. Okay. But then when you work on your assignments, you have to explain on what does this mean? Mean 20.9, so what? Standard deviation is 12.05, so what? You need to answer this question on so what. Okay, please remember that. Try to think through and then answer. Okay, I believe that the standard deviation is 12.05. That means the variance is high, variation is high, or variation is low. Uncertainty in the data is less. So I foresee that the final result will be better. In that way, you have to. Sure. And wherever you have categorical data, you can also perform label encoding. Label encoding means you're just trying to convert the categorical data into some numbers. Should I always do it? Not needed. If I open and close the braces, label encoder, and if I do not mention anything within that, what hyperparameters will it choose? What options will it choose when I just open and close the brackets? It will choose all the options. Okay, within this, whatever are the various options available, it will choose all of that. And what are the default values which it is going to use? It is going to use the default values which are available. Friends, come on, this is a little, okay, anyways. So whenever you have any function, within that function, you will have hyperparameters like this, which are options. If I do not give anything within that, it will take all the hyperparameters available in that. And the default values assigned to that will be taken. But if you feel I don't want default values, I'm going to supply some value, then supply it like this. Criterion equal to entropy, supply in that way. Then the algorithm will understand that, hey, this person is saying that don't choose your default criterion value, choose entropy, is what it understands. If I say help of dt, it will give me list of all the hyperparameters which are available. In that way, for every function within Python, you will have list of hyperparameters. Okay, which are options, which can be changed and experimented. What happened? We have run these many algorithms and still you're like, what is he talking? I each time repeated this. Each time I repeated this. I don't mind repeating again whenever that appears, but each time you sleeping is not done. Okay. So number of features, number of outputs. Okay, so there are many other options. So maximum, how many features do I need to use? What is a random state? What is the maximum number of features, right? What is a random state value? All these are called as what? Minimum impurity decrease, maximum leaf nodes. What are all these called as? Hyperparameters. Okay, every function will have such set of hyperparameters, and every hyperparameter will have a default value. Default value, right? Everything will have a default value. Okay. So if I open and close the brackets, and if I do not mention anything in that, then what will it choose? All the hyperparameters pertaining to this function. And all the default values will be taken. If you want to know on what are the various hyperparameters, what should you do? Help of, okay, whatever is given here, type that. Okay. And when you run this, it is going to give you list of all the hyperparameters which are available within this function. Okay. These are examples, etc., which are available. Yeah. You can. If it is discrete or if it is numeric, if you feel that I want to create buckets, do so. If it is this. But if your common sense says that, no, I want these to be not converted into discrete variable, but these are count like 6 months, 48 months, 12 months, let it be as is. If that is what your logic says, let it remain as is. There is no hard rule that if you see numbers discretized, that is not what I'm saying. Based on whether it is really applicable there or not, you decide. Nothing of that. There's nothing of that. But the only thing is, if you have an algorithm which behind the scenes does some multiplication, addition, subtraction, deletion, square root, and all that, then obviously you need numbers. So given your data, you convert it into numbers. Sometimes your algorithm itself will tell you that it will throw an error message saying that this data cannot be processed because you need to convert that into numbers, numeric, and convert it. Certain times algorithm itself will convert to numbers. Either it will do one-hot encoding or label encoding. In some fashion, it will only convert. Okay. Both. All the techniques on the planet, I repeat, all the techniques on the planet, except for regression techniques, can be used both when your output variable is continuous or numeric, and it can also be used for output variable which is discrete, categorical. So we need not worry whether output variable is numeric or non-numeric. We need not worry. Job done. That's it. Simple. When we get into regression techniques, then we'll understand that when output variable is discrete, categorical, in two categories, then you use logistic regression. If the output variable is numeric, then you use linear regression. That classification comes there. Apart from that, every algorithm can be used for every purpose. Okay. Certain algorithms, if you supply numeric data, it would convert that numeric data into categorical. Okay, it will automatically do the discretization. One such algorithm is your decision tree algorithm. Okay, so here what we are doing is we are taking each and every categorical variable like checking balance, credit history, all these are categorical variables. We are performing label encoding. Should I do it? Not needed. Why are we doing it? Just because one additional option will be explained to you guys. That's it. There are many options, right? In every algorithm, we put certain options. We're putting some options here. Okay. So where is data here? If you see, we converted everything into numbers. Okay. If it is integers or float, it would convert and do the analysis. But if it is object, then it will not. Object means, what is object? Categorical. If I tell male and female, 0 is male, 1 is female, will that be numbers? Or numbers or object only? Just because you put 0 and 1 doesn't mean it will start treating that as integer. Right? It is still categorical data only. Just that you convert it into numbers. Makes sense? Okay. Where we have Madhuri, I could not find it. If you found it, wonderful. Let me know, please. Yeah, Madhuri. In which column? I wish to open that column and then check. Where do you have missing values or unknown values? Yeah.
In checking balance,
Okay, I'll go here. Unknown is one category. Unknown is one category within this.
Okay, and also in saving balance. Okay.
Okay. That is one category, Madhuri. It's not missing value.
Okay.
Okay.
Fine.
If it is a missing value, what you should have done is converted. You should have written a code wherein that unknown value would get replaced into NA value or NAN value, and then you drop it or input it, right?
Yes.
Yeah. Okay. So if you go to data, default is one column here. Default is one column here, and default has entries such as no and yes. And the data type is object. Value count. No has 700 entries, yes has 300 entries. Do you think it is balanced dataset or imbalanced dataset? Okay, maybe balanced, maybe imbalanced because it's just on the wall. All right. But less than 30, it's just one number. I mean, if I would have had one number less in this, then that would have been called as imbalanced, right? Going by our rule. So we can also treat this as imbalanced. but we will see how to deal with balance versus imbalance.